Hi, thank you for joining us. I'm John Anderson, the Territory Manager for Western Canada for Kryton International. Also joining me is Mr. Jeff Bowman, the Director of our Research Center. Jeff, thank you for joining us.
Glad to be here, John.
Today, we're going to be talking about the durability of concrete, the damage done to concrete by erosion and abrasion, and how to offset that with the admixture, the concrete admixture Hard-Cem. For some of you, this might be a refresher for Kryton. You may have bumped into us in the past. And for others, this might be an introduction to Kryton. We are a manufacturer of durability enhancing concrete admixtures and surface applied products. Our admixtures are KIM, crystal internal membrane, which is a crystalline admixture, which waterproofs your concrete, Confume, which increases the durability, and Hard-Cem admixture, which we'll be talking about today, that increases the durability and the resistance to abrasion and erosion. We also have surface applied materials that restore and protect your concrete. Kryton is a family-owned business based in Vancouver, founded in 1973. We have offices around the world, and we have projects now in over 55 countries. So Jeff, let's take a moment and talk about the problem, the wear created by abrasion and erosion of concrete.
Thank you, John. I think to start, it's important to just take a review of exactly what we're talking about on concrete and its abrasion resistance. Broadly speaking, the resistance of concrete to abrasion depends on three factors of that concrete, and those are the strength and density of the aggregate you're using, the strength and density of the cement paste that's binding them all together, and the bond strength between those two materials. Now, broadly speaking, it's well recognized that the abrasion resistance of concrete does correlate directly with compressive strength, but in all cases, it's the cement paste is the weakest and most vulnerable component of that concrete where the abrasion is taking place. And when we're talking about abrasion, we mean some sort of loss of mechanical material due to mechanical action on that concrete. It starts at the surface of the concrete and it works its way down. So in this respect, abrasion resistance is a local property compared to compressive strength, which is a bulk property of that concrete. Now, what this means is two very similar concretes with similar materials and similar bulk properties can have very different local properties like abrasion resistance, depending on exactly how they're placed and handled during casting and finishing of that concrete. Now, abrasion is going to occur by any sort of mechanical action of objects rolling, sliding, or grinding over that concrete, and it can really be enhanced if there's foreign materials trapped between the concrete and that object that is acting on it. Another process that can damage concrete is erosive wear. Now, erosion will be any sort of deterioration due to the action of water, particularly if you have high volume and high velocity water flow moving over that concrete. And this can also be significantly enhanced if there's foreign particle impact combined with that erosive wear.
And Jeff, this is why British Columbia Hydro added Hard-Cem to the concrete in all of their pump houses and spillways to offset the damage caused by the water repeatedly pounding into the concrete. They also added Hard-Cem to their maintenance facilities to help with the damage that may be caused by vehicles and equipment traveling across the concrete. Now, when we think about the significance of wear of concrete, we typically think about the cost associated with taking a facility out of service, tearing out concrete and replacing it. But there's also a significant cost associated with the health factor of tripping hazards, the safety, and the employees breathing in the dust caused by the paste of the concrete being worn down and blowing throughout the facility. There's also a cost associated with machinery, which wears out, has to be maintained and also replaced. This is a really interesting case study of the performance of Hard-Cem. The facility placed Hard-Cem concrete in one area, and right next to it, they placed control concrete or regular concrete. After 14 years, they invited us back into the facility to have a look at the performance. And as you can see, the nice shiny concrete surface with strong edges across that line there, that's Hard-Cem concrete, really good performance. The concrete next to it has been worn down, the paste is down, and all that dust you see all over that the Hard-Cem concrete is that paste and is that safety risk and hazard. A great story and a really good performance review after 14 years of in-service performance in exactly the same environment. Now, Jeff, there are some traditional ways of reducing concrete wear. Let's take a moment and talk about these.
Absolutely. John, I think one of the first areas where people will turn to when they're trying to specify a more abrasion-resistant concrete is to use something called a dry shake hardener or a broadcast hardener. Now, these products will consist of cement, some sort of additives, maybe finishing aids, and then a wear-resistant particle, often a metallic aggregate or aluminum oxide, which is emery, a very hard-wearing aggregate. And these products get broadcast over the fresh concrete shortly after it's been placed, and then troweled into the surface during final finishing. Now, if these products are well installed, they can really work to give you a nice abrasion-resistant finish, but they do have a very significant weakness, and primarily is that they are quite difficult for the contractors to install. And I think you can really see why if you take a look at this table here on your screen. This has been taken from ACI 302, which is the Guide to Floor and Slab Construction. And you'll see partway through, after striking off and floating your concrete, there's a split where it asks whether you're using an embedded hardener or pigment. And if you're not, you simply wait until the concrete is ready to finish, you apply your normal finish, and you get on with your day. But if you do need to apply one of these products, there are now many steps that need to be performed. The products are applied in multiple passes. There's work that needs to happen in between these steps before you finally get around to doing your final machine finish. Now, the problem is, anytime you add complexity to a contractor's job, you're adding opportunities for them to make mistakes. And all of these steps that need to be performed can be very time sensitive, and it's quite easy for the contractor to miss that window of opportunity to apply the products properly. And quite frankly, this step comes up at the end of the day when the contractors are also just getting fatigued. They've been working at it all day, they're getting tired. This is a lot to place on them at the end of the day. So some of the challenges they're going to have. These dry shakes are very sensitive to the bleed water on your concrete. You need just the right amount of bleed water at just the right time. If they apply the products too soon, when they trowel it in, they trap the bleed water, and this can cause delamination in their surface. If they wait too late, the concrete slab will simply set too much, and it just won't accept the dry shake. They can't get the full specified amount applied to the concrete. They're also going to be battling wind. If it's windy, this dry shake is going to be blowing all over the job site. You can't get it uniformly applied over your slab. Often they have to put the roof on their structures first before they cast their slab. So this can really affect the schedule that they're trying to work with. And they also can't be applied over air and train concrete because the troweling needed to work them in can cause delamination when you apply that troweling over air and train concrete. So there's a lot that they have to deal with.
Jeff, you've just described the conditions that Graham Construction experienced while building North America's largest pea protein plant in Manitoba. They have large slab pours, and during the first slab, the specified shake-on hardener, they're having a challenge of getting that down in that very finite window of opportunity. And they ended up losing the first slab. Graham then approached the engineer of record, suggested that Hard-Cem be used. The engineer did their diligence and approved Hard-Cem for the balance of the project. And they did end up having to remove that first slab and replace it. So exactly the conditions you explained of the end of the day, trying to get down that shake on, and they eliminated that by adding Hard-Cem into the back of the concrete truck at the batch plant. Now, by doing that, you've also eliminated the health risk associated with using a shake-on hardener. The provinces of Canada and the states, many of the states have very tight controls of how much silica exposure is allowed on a job site. And that translates into very difficult controls to maintain and also very expensive controls to try to keep our workers safe. This is all eliminated by simply adding the Hard-Cem into the back of the concrete truck. Now, Jeff, there are also some materials, some silicate formulas that are applied after the concrete is placed and cured. Let's take a moment and review these.
Of course. So one type of product that could be very tempting for people to turn to are liquid hardeners or liquid densifiers. And these products are usually quite easy to install. They go onto the concrete after it's hardened, and they can be quite economical. And when we're describing a Hard-Cem or a liquid hardener densifier, this is usually some sort of silicate-based product that gets applied to the concrete to help densify that top surface. Now, the way these products work is they function by reacting with the calcium hydroxide in the concrete. Calcium hydroxide, of course, is a byproduct of cement hydration. And when these products react with calcium hydroxide, they produce more CSH, or calcium silicate hydrate gel. And this is the normal product of cement hydration. It's the good stuff that gives cement paste all of its strength and binding properties and holds that concrete together and really makes concrete concrete. Now, this basic reaction product of reacting with calcium hydroxide to strengthen the paste is quite similar to how SCMs work, such as fly ash, slag, or silica fume. So one of the consequences of using a liquid hardener is they may then start competing with your fly ash or slag for this calcium hydroxide. In fact, so much so that many suppliers of these products recommend limiting the amount of fly ash or slag you use in your concrete, or they may recommend delaying the application for up to 28 days because they want to allow the concrete to come up to its specified strength before you apply the hardener. Unfortunately, these limitations are not always compatible with a modern construction project. More and more SCMs are being used for a variety of reasons, and sometimes you can't wait 28 days to get something done and check that off your list. So if you are looking at these products, you really need to examine them carefully and see if they really fit with what you're trying to accomplish. The other significant limitation, though, is they're often miscast as an abrasion-resistant material for concrete. And there's extensive research on this. Floor consultant George Gardner's work is really interesting. You can find it online, you can look it up. But he's examined them quite closely, and he's found that they simply don't significantly move the dial on abrasion resistance. Now, the reason for this is what we just touched on. These hardeners work by slightly increasing the amount of hydrated cement paste in your concrete. But we've already identified that the weakest component is the cement paste. Just having a little bit more doesn't really change the situation. It helps a bit, but not that much. Now, these products do have a role. They were originally brought to market because they were effective if you had a slab where the contractor had some difficulty getting a really good finish on it. Maybe it was windy and the surface dried out too soon and the cement didn't hydrate very efficiently. So it's weak and dusty basically from the first day you install it. These products can help as a remedial measure to try to strengthen that slab, but they're not really appropriate when you're trying to specify abrasion resistant materials for new construction. Now, if you're not using dry shakes and you're not using a liquid hardener, the third option many people will turn to is, why not just use higher strength concrete? We already touched on it at the beginning. Abrasion resistance broadly correlates with strength. So why not simply use higher strength? You can add more cement powder, you can increase fly ash or slag, you can use silica fume, you can keep the water cement ratio very low. There's lots of options to increase your strength, and you can normally increase your abrasion resistance along with it. So why wouldn't everybody do this? Well, the reason is there are some added risks to simply using stronger concrete. Anytime you're adding more paste, you're increasing the amount of hydration, there's more heat, there's more shrinkage. But you can see here, you do get higher strength. Broadly speaking, when you double your strength, you're doubling your abrasion resistance. But for some applications, this will work. For others, it can introduce a lot of unintended consequences that significantly affect the final use of that concrete, especially if you're looking at a floor. The higher paste mixes generate more heat. Heat produces more shrinkage. Shrinkage produces more cracking. And if you're building a warehouse floor, when they start to dry out, they tend to curl up at the edges. So your floors don't stay as flat. which is a significant problem because one of the primary things we expect from our floors is they stay nice and flat so our equipment can move efficiently over top of them. So all of these things are actually really bad. They directly go against what you're trying to accomplish in your project. And as another consequence, using that higher strength concrete and using more cement and cementing materials increases the carbon footprint, the environmental cost of that concrete slab, which also works against what a lot of people are trying to accomplish on their projects today.
So what is the solution? It's adding Hard-Cem into your concrete at the batch plant. The Hard-Cem becomes a permanent part of your concrete paste. It strengthens it and resists abrasion and erosion. It also reduces the job site silica exposure to your workers. It's easy to apply. There's no negative effects on your plastic or hardened concrete, and it can be used in air and train concrete, which means for the first time you can add a durability product outside in air and train concrete. It can also be used in horizontal and vertical work behind formwork and with shotcrete and precast. It outperforms the Shake hardeners, as Jeff so nicely explained, the process of trying to get a shake on down and the difficulty in it. You simply add it into the concrete and you no longer have to go through that whole process. You add it to the concrete, you place your concrete and finish it. It simplifies the process. It's proven, it's been around over 18 years and in 60 million square feet in almost every type of application you can think of. A lot of the major concrete companies have a branded concrete mix for durability, and they're using Hard-Cem to achieve that durability. So Jeff, let's talk a little bit about the performance you can expect when adding Hard-Cem into your concrete.
Absolutely. There are many abrasion-resistant test methods that have been published by Astm and other agencies, but I think the really interesting one I'd like to focus on today is Astm C627. This is often called the Robinson test or the Robinson floor machine test. And the interesting thing about this test method is it applies a really heavy load compared to other test methods. And in the early days of developing Hard-Cem, Dr. Rusty Morgan, at the time with AMEC, recommended this test as the most appropriate to develop Hard-Cem and really prove its worth in heavy-duty applications. He thought this test really did a good job of recreating real-world conditions and really aggressive high-load applications, but it also had the advantage that the test panels were quite large. They were several square feet, so you could really recreate realistic casting and finishing techniques to really recreate the type of slab condition that you would be dealing with in the real world. So when this test is run, that machine we were just looking at, it rotates. Typically, we run it for 5,000 cycles. You can modify that test and run it for longer if you'd like. And when the test is done, you can directly measure the depth of wear that's been cut into the concrete by these hardened steel wheels using a pair of depth calipers and measure the abrasion resistance of the concrete directly. Now, looking at a common example, this is using a 25 MPa or 3000 PSA concrete, very standard conventional concrete like you might use on a slab on grade or a warehouse floor. And you can see that the depth of wear using Hard-Cem was about half what was experienced just using the plain concrete. So a very significant increase in the abrasion resistance and resiliency of that concrete. And again, because this test method gives you nice large test panels that really recreate the finishing techniques that would be used in the field, it's also the ideal test method to compare Hard-Cem to some of the other technologies we were talking about earlier. So looking here, a test program was performed using Hard-Cem, comparing it to some of the common dry shake products that are on the market. Now, among the dry shakes, there's a range of materials, as you might expect. Some work very well, some not as much. But what you can see is that by using Hard-Cem, not only are you still getting top abrasion performance, consistent with the best dry shakes on the market, but you're still getting this in a product that is much easier and much more reliable to install. So you're actually a lot more likely to achieve that performance in the field.
Jeff, this is a great example of the performance we can see in real world environment with Hard-Cem. This has been placed at a concrete batch plant where the heavy machinery, the loaders, and the trucks are constantly driving over the concrete. The concrete company placed the Hard-Cem concrete directly next to control concrete. And after 4 years, you can see that the control concrete has worn down the paste right down to the aggregate. And then in the Hard-Cem sample, we can still see the brewing of the concrete while they're finishing it. It's a great example of the performance that you can expect to see in a very harsh environment. So Jeff, you mentioned earlier that Hard-Cem plays into part of a carbon reduction strategy. And this is a reality that all the projects we're seeing now, it's the world we're living in where we're forced and mandated to reduce the carbon on the project. And it's a good thing. Jeff, can you take a little time and talk about how Hard-Cem does play into part of your carbon reduction strategy?
Yes, but to start, we'll just quickly review, some of the background information. I'm sure a lot of people are familiar that most of the carbon emissions associated with concrete are from the manufacture of Portland cement. And roughly for every 1 ton of cement manufactured, 1 ton of carbon dioxide is released. Now that's quite a bit. But more specifically, we're looking at the total carbon footprint of the concrete itself, the combination of all the aggregates, other materials, mixed and delivered to the job site. And there are some really good industry resources we can use to estimate this. The one we'll draw on today is from the Canadian Ready Mix Concrete Association. Their Environmental Product Declaration, or EPD, covers a range of producers surveyed across the country. And from this resource, we can see that the carbon footprint of concrete can typically vary anywhere from 250 to 500 kilograms of carbon dioxide per cubic meter. So you can think of this like an investment in your concrete. You've made this environmental investment. You really want it to last, so you don't need to spend more fixing or maintaining that concrete later. So how is Hard-Cem going to help? Well, really, there's 2 ways. There's future reduced maintenance and the ability to avoid the unnecessary use of higher strength concrete where that can be appropriate. So let's take a look at higher strength concrete. We know that using a high strength concrete, looking at our industry resources, the carbon footprint of these materials are typically higher, 350, 450 kilograms CO2 per cubic meter. But for many applications, because they could produce more shrinkage, more cracking, more curling, even though the abrasion resistance is very good, sometimes they don't actually deliver the best, most balanced solution, even from a performance point of view, when you factor in all the things that the owner wants on that project. By comparison, if a more conventional concrete, perhaps 25 MPa in this example, if that concrete is considered to meet all of the strength and engineering requirements of the project, you can use Hard-Cem to still design that mix for abrasion resistance while still taking advantage of the more environmentally friendly and lower carbon footprint of that mix. And you can do this without introducing some of the other problems you might have with shrinkage and cracking and curling in your slab. So it really allows a unique opportunity to design for durability and abrasion resistance and the environment at the same time. You don't need to compromise on those 2. Of course, what about later on? We know that over time, no concrete is going to last forever. Quite often there is going to be maintenance, either to restore the concrete or to restore maintenance and operations and serviceability of that concrete. So anytime you can reduce the need to grind down and resurface your concrete, or possibly replace your concrete entirely because it's so badly worn, over time, you can significantly reduce the lifetime carbon footprint of that concrete just by designing it to last the first time. And we have a really interesting case study on this. The new Afton gold mine, this is near Kamloops in British Columbia. It's actually a reclaimed mine where they go back in and they're able to continue to harvest that gold vein. And this mine reopened in 2011, but they experienced severe wear on their concrete in their ore collection and processing area. So much so that within 3 years, they had to replace the concrete in that area. But when they did, they replaced it using Hard-Cem in their concrete, and that concrete is still performing well today. Now, if you break this down and look at their original maintenance schedule where they had to completely replace it every 3 years, using Hard-Cem has helped them to skip at least 2 replacement events, and they're actually about halfway through a third. So looking at the carbon investment in that original construction, by using Hard-Cem, they've been able to reduce the carbon footprint of that concrete by almost 50% as of today. And if they'd used Hard-Cem the first time, that number might be even higher. So this really shows how creative use of admixtures can allow for very efficient and creative environmental solutions while still getting very high durability.
Jeff, what a wonderful time to be working with concrete. Gone are the days of concrete simply being sand and cement and water and aggregate. Now we have exposure to high performance concretes that give you design flexibility and help increase durability, extending the service life of your concrete. Admixtures like Hard-Cem. So in summary, Hard-Cem protects against the abrasion and erosion and damage caused to concrete. It's very easy to install. It reduces safety factors like tripping hazards, fall hazards, and exposure to silica dust. It plays a role in your carbon reduction strategy for your project. It's been in service over 18 years and in 16 million square feet. A great product to be adding to your concrete. For questions, please feel free to touch base with us. Thank you so much for taking time to join us. I hope you found this to be of value. Jeff, thank you also.
John, pleasure as always.